Alright, so today we're going to start our lesson on trigonometry. It's my favorite lesson to teach of all. And if you take this big long word trigonometry and you break it up, it's talking about trigons. Well, you know what a trigon is? It's really a triangle. Trigon means three sides. And so I honestly don't know why we stopped, like we have octagon and pentagon and hexagon. I don't know why we didn't just stick with trigon. I don't know why we switched over to triangle, honestly. But a trigon just has three sides, so we're talking about triangles. And then anytime a word ends with metry, it means to measure. So like this course you're taking is called geometry. That literally means to measure the earth. So in geometry we learn how to measure line segments and triangles and squares and rectangles, and next we're going to get into measuring 3D objects, prisms and pyramids and spheres, just measuring stuff, all the stuff of the earth. But trigonometry is specifically measuring triangles, and it is specifically measuring right triangles. So in the middle part of your page, I need you to draw a pretty nice sized right triangle, like so. And we're going to start with one thing we know already. So we already know that across from the right angle is named the hypotenuse. And then we're all going to abbreviate hypotenuse the same way. We're going to abbreviate it HYP for hypotenuse. And so we already know that if we know two of these side lengths, we can use the Pythagorean theorem to find the third side. So we know that already. But what if we only know one side and one angle? That's when we're going to use trigonometry to find out the other sides. So let's say I have this angle, and most of the time angles are marked with this Greek letter. It's called theta. So this sign right here is theta. And that is a Greek letter. And you might see theta or other Greek letters if you drive by UNT and you see the sorority and fraternity houses. Sorority and fraternity names usually have Greek letters in them. Some of them might have the letter theta in their name. But it's just a variable. So it's like x. In fact, when you look on the calculator and you see the button that has the x, you'll see that that also has a theta on there. Right? So it's just a variable, but it's a variable that we typically use for an angle. And so if this angle is theta, the side that's across from the theta, this side is called the opposite. It's opposite from theta, and we abbreviate that one OPP, opposite. And then this side, the side that is next to theta but is not the hypotenuse, that is called adjacent, because adjacent means next to, and we abbreviate that ADJ, adjacent. So I'm just going to come in here and color code these. If you're a person where color coding helps you to organize stuff, so we have the hypotenuse. Right there is always across from that right angle. That's how you know your hypotenuse. And then we have our opposite side, is this side right here. Opposite, because it's opposite from theta, like that. And then we have our adjacent, and adjacent means next to. So your adjacent is your one that's next to theta. Alright, so first thing, to see how well you can organize this information for yourself, I'm going to draw a different little right triangle down here, and your job is to mark hypotenuse, opposite, and adjacent, where you think they go. Alright, so take that triangle and label HYP for hypotenuse, OPP for opposite, and ABJ for adjacent. Alright, let's check yourself, see how well you did. Here's your right angle, across from the right angle. So check and see, did you put hypotenuse right there? If you did, good job. If not, write it in now. Then here's your theta. You go across from theta, and that's your opposite, OPP. And then this one here, that's next to theta, that's the ABJ, adjacent. So, if you got all those right, give yourself a smiley face, star, pat on the back, good job. Alright, now we are going to work on our foldable. So if you are a connected learner, I sent an email. These are downstairs in the front office. You can come pick one up. Or on my email, if you have a printer, you can print it out. But if you can't do that, it's okay. You're just going to write in your journal. But if you have this, it kind of helps keep things organized. So this SOHCAHTOA is a made-up word, okay? When I was in school and I first saw it, to me it sounded like a Native American tribe, like Cherokee or Choctaw, SOHCAHTOA. It sounded Native American, but it doesn't have anything to do with that, honestly. And it's not a real word. It's a word that's made up to help you remember. So every place there's an O, that stands for opposite. Every place there's an H, that stands for hypotenuse. Every place there's an A, that stands for adjacent. Okay? So today we're just going to learn how to set up these different trig ratios. Trig ratios. A ratio is a fraction. Trig is short for trigonometry. So we're just going to learn how to set up the fractions. Alright, so we're going to take our foldable and we're going to open it. And so the first one up here is for sine. The S is for sine. And that's the first part, so. It's S-O-H. And that S is for sine. And sine is one of our trig functions, one of our trig ratios. And so sine is opposite over hypotenuse. So here's my right angle. This is my hypotenuse. Here's my theta. So this is my opposite. And so the fraction goes like this. We abbreviate sine, S-I-N. And I know that looks like the word sin, but don't call it sin, because if you call it sin, people will think that you don't know anything. it's sine theta, and it equals a fraction, and the fraction goes opposite over hypotenuse. So there's your S, your O, and your H. Alright. Then our next one is named cosine. That's where the C comes from. And that's so-ca, it's C-A-H. And so that needs the adjacent and the hypotenuse. So my hypotenuse is across from my right angle. And my adjacent has to touch my theta. So adjacent is right here next to theta. And my fraction goes like this. Cosine, we abbreviate COS. Cosine theta equals adjacent ABJ over hypotenuse, HYP. Alright, and then our last trig ratio that we're going to learn about is named tangent. And so that's where the T comes from. And this part goes TOA. So-ca, TOA. And so tangent has an opposite and an adjacent in it. So here's my theta. So we go across from theta. That's the opposite. And then next to theta, that's the adjacent. And so our fraction goes tan theta, so tangent, we abbreviate TAN, so it's tan theta equals opposite over adjacent. Alright, and so for today, we're just learning how to set it up. Tomorrow, we're going to do this side and learn the problems. But let's do an example of just how to set it up, and then you're going to do a little bit of practice on iExcel. So I'm going to go back to my notebook, and I'm actually going to write a problem that was on the iExcel. And it says, cosine of angle V. And then it had this picture on here. So these are the kinds of problems you're going to see on your iExcel today. And it's just getting you to practice how do you set it up. So, and I suggest when you do your iExcel that the first maybe 2, 3, 4 questions, you draw them in your journal. And then after that, you'll probably be like, okay, now I kind of get the hang of it. So first of all, angle V. So that means I'm going to go here to the V, and that's my theta right there. And then it says cosine. So when I go to my notes, I say cosine. I need adjacent and hypotenuse. So I'm going to come here and label. I always like to start with the hypotenuse personally because I always know it's across from the right angle. So that's the hypotenuse. And then I need the adjacent. The adjacent is next to theta. So that's the 5 right there is the adjacent. And I don't need to worry about the opposite because that's not part of cosine. See, there's no O. I don't need that. So then I look in my notes and it says cosine theta equals adjacent over hypotenuse. So that would be cosine of V, because V is my angle on theta, equals adjacent over hypotenuse. So that would be 5 over 13. And that's what I'd type in IXL. And I'd hit enter. Now, one tricky thing before you start working on your IXL is, what if you do a problem and your answer comes out to be 12 over 24? If you type that in your IXL, it's going to say wrong, because they want you to simplify, right? So whenever you get numbers that can simplify, like 12 can go into 12 and 12 can go into 24. So 12 over 24, if you divide them by 12, is actually 1/2. So a lot of them, like 5 over 13, you can't simplify. But if you get two even numbers on top of each other, make sure you simplify first, right? Because even numbers can always be divided by at least 2.